Hello people, welcome to my first video tutorial of meshing in Hypermesh. So let's see what we'll be doing in this tutorial. Okay, these are all the things we'll be doing in this tutorial. Okay, we'll start while importing the geometry in Hypermesh, then we'll do the basic card kind of thing, and then we'll create the solid mesh for the component. Okay, most of the tutorial will lead you up to this only, but since we'll be solving this model in Ansys APDL, we have to do some more steps, and that will be creating the entity sets, creating the materials, assigning those materials, element types, and the real constants. Okay, and then we'll export the solver deck for Ansys mechanical APDL utility. So there will be a series of tutorials wherein I will show how to create a solid mesh in Hypermesh and then solve the same model in Ansys Mechanical for various cases. Okay, so let's take a look to our geometry. Okay, this is our geometry that we'll be using for this tutorial. So as you can see, this is a cylindrical pressure vessel, and it has two spherical ends and one nozzle opening over here. Okay, so I have modeled this geometry in CATIA. You can model any similar geometry, any simple geometry of yours using any of the design softwares, geometric modeling software. Okay, if I deactivate the split, you can easily see that. Okay, this is our geometry, and I've saved this file as an STEP file, step file. Okay, so without wasting much of time, let's go to the Hypermesh and make this model. Okay, so just click on the new session, start a new project, click on the new session. Now to import the geometry, we'll simply click on this import icon, and then you have to click on this import geometry icon. Okay, here you have to click here, and then you have to navigate to your the location where you have saved your geometry file. Okay, here is my geometry for the practice STP. I have saved it as practice STP. I'll click on this file. Okay, so you can see here the list of files that you have selected. So I'll click on this file. Okay, sometimes you have to import multiple files at the same time. Okay, so there is a list which all the files you want to import. So I'll click on this file name and I'll just say import. Okay, so it has imported the file. Quickly I'll tell you the meaning of viewing preferences over here. Okay, the first, if you can see, there are first three options in this toolbar are the viewing preferences for geometry. Here you can set your viewing preferences if you want to view the geometry by component. If you click on view the geometry by component, you can see the whole body turns into red. Okay, it actually shows you geometries by their components. Like there may be different solids and different components. Right now there is only one component named practice. It has a red color. Okay, when you click on by topology, it will show you geometries by their topologies. So if there is 3D body, it will show you into green. If there is surfaces, it will show you into gray color, and it will show the edges of the surfaces will be shown in different colors depending upon their connectivity in the surfaces. So right now we want we have this solid body, and we actually wanted our body to our geometry to be a solid body. So it's good, we have this solid body. Okay, and these three options are the viewing preferences for the elements. Okay, similarly you can see the elements by their component, by their properties, the properties that we have assigned for the elements, or by the material that the elements have been assigned with. Okay, you can see the elements by their types, 1D, 2D and 3D, by their thickness, by their quality. Okay, when you click here, it will show you the geometry in wireframe view. So sometimes it's really useful to see your geometry in wireframe. Okay, it helps you to access the surfaces or the areas of geometries where you can't go with your normal view. And to get back to the normal view, you just have to click on this shaded geometry and surface edges option. Okay, so that's it. Okay, one more thing I would like to tell you about the zooming, panning and rotation control in the Hypermesh. Okay, just give me a second. Okay. Okay, so it's very simple to control geometry, adjust the views in Hypermesh. You can rotate the geometry just by holding the control and with your left mouse button. Similarly, if you want to pan the geometry, just press control and use your right mouse button. To zoom in and out, you can use control and your mouse wheel. Okay, it's very simple. To rotate, use control and left mouse button. Pan, use control and right mouse button. To zoom in and zoom out, use control and the mouse wheel. Okay. So let's just start with the CAD cleanup. Now this, if you can see this is a solid body, but the whole body is a single solid, and to start meshing we need to split this body into different solids because we can't mesh this entire body in a single step. So that's why we will have to create some splits, create some new solids, to basically to make the geometry meshable. We have to do some CAD cleanup. Okay, simply go to geometry page, click on solid edit. Okay, so we'll split this body. Okay, this is a symmetric body, and it's symmetric about side X plane. As you can see, it's symmetric about side X plane. You look from the XY direction, you will get to know that this body is symmetric about this line that is X axis. Okay, so to split this body on this symmetric plane, we'll use this option, trim with plane or surfaces. So we'll trim it with the plane, but to do that we'll have to create a node first. And to create node, go to geometry page and go to the nodes tab or nodes panel. Okay, there is one more simple way to go to there, this nodes panel. Okay, you can simply press F8 from your keyboard and you will be directly into the nodes panel. Okay, using shortcuts, keyboard shortcuts, it's a very effective and powerful way to use Hypermesh. Okay, you can use all the features of the Hypermesh, all the options of the Hypermesh from this panels list here. But I would say it's not a very professional way. It's kind of boring way. So just try to use more and more keyboard shortcuts. I have uploaded the list of keyboard shortcuts in the description, a link for the file that contains all the keyboard shortcuts of the Hypermesh. You can download that file and you can use those keyboard shortcuts. So right now we'll press F8 on my keyboard, and then I'll select the third option to create a node at the center of the line. So I'll just select the okay. Here you have to turn this change this option into lines. Okay, either you can create nodes at the center of some nodes, at the center of some points, or a line. I would go for line. Okay, so I'll change this to line and I'll select these and these two lines. Create. So a node has been created. Okay, after creating node, let's go to the solid edit panel. Okay, go to the solid edit panel, go to the third option or third tab, that is trim with plane or surface. Select your solids. Okay, I want this solid to be splitted. Okay, then you have to choose the axis about which, or what you can say, you have to select the axis. If you want to split the solid about Z plane, you should select the remaining axis. So I want to split my solid about Z plane, and that's why I would select Y axis, and we have to choose a base point. That should be a node, and that's why I've created a node. So I'll select this node and I'll just say trim. Okay, the solid is trimmed. You can see that very easily this solid is the whole body is split into two bodies, into two halves. Now we'll delete one of those halves. Okay, so set in this view, return. Okay, now you can either click to on this button of delete, or else you can press F2 from your keyboard. F2 is the shortcut for the delete panel. Okay, then I'll go to this solids. I'll select here solids, and I'll make sure that there is tick mark, or the checkbox is having tick for delete bounding surface and delete associated elements. So okay, there are no associated elements right now, but I want to delete the surfaces associated with this solids also. So I'll delete this half of the geometry. Now I will mesh this half of the geometry, and I'll reflect these elements so that most of my time is saved. Okay, so we have spread the geometry into half. Now you can see here some extra edges. I don't want these edges because these edges will create problem when I'll be mapping, or I'll be meshing with solid. So I have to remove these edges, or remove these lines. More precisely, we can say that I have to remove these lines. So how can I do that? You have to go. Okay, it's very simple in action. You should go into this quick edit panel. In geometry page, you have to go quick edit panel. Now the keyboard shortcut for this quick edit panel is F12. Simply press F12. Sorry, F10. Simply press F11 and you will get into the quick edit panel. Now click on the toggle edge option. Okay, click on this line. Click on this line. It will be turned into a dotted blue line. That means it's the edge is still there, but it won't affect your meshing and all those things. It simply will be ignored. Also this line, also this line, this edge, this edge. Okay, so we have removed all the extra edges. Okay, if you want to untoggle this, you just have to simply you right click on that edge and it will be released again. So I'll toggle it now. Okay, great. Okay. So now yes, we need still some more split to make sure that we get a good quality of mesh. So let's start splitting those solids. We'll again go to solid edit tab, and now we'll use this option, trim with lines. Trim with lines. So now select the solid, and I'll select these two lines. I'm using this third option, that with bounding lines. So I've selected solid, I've selected these two lines, and I'll now trim it. Okay, I got it. Again, I select this solid, I select these two lines, and okay, trim is done. Now what I want to do is I want to split this shell somewhere here to make sure that I get a good quality of mesh. So how can I do that? I'll again go to the nodes panel, that is to create nodes. I will press F8. I'll select this point, I create a node now. So how I can split this is I will simply translate this node. To translate the node, you can go to tools page and you can open this translate panel here, or simply the keyboard shortcut is just press shift F4. You have to press shift F4 to open the translate panel. Okay, good. I'll click on this node and I'll set the axis. I want to translate it in X direction, so I'll select the X axis and I want to translate it by 10 mm in negative direction, so translate minus. So I pressed it 2 times to make sure that I translate it by 20 mm, and one more time. Okay, this is very good location. Okay, so we'll again go to geometry page and solid edit panel. trim with plane. Okay, this time the solid is this. Now I want to split the solid about Z y plane. So that's why I will select the X axis, the remaining axis, and I will select this node as base point and I will trim. Okay, trimming is done. Now I want to detach this nozzle from the shell. So how can I do that? Okay, I'll go to trim with lines tab, you can say. I select this solid, I'll select this line. I'm using the sweep line option. Okay, so here you can see there are some more unwanted edges that we have forgot to toggle. We can toggle them now. Just press F11, click on the toggle edge option. Okay, toggle this is also, toggle this is also. Great. Now let's go back to the solid panel. Okay, so we'll be using this sweep line option. We'll check this solid. I will sweep this bigger edge along the Z axis to split this solid. Okay, so simply change the axis to Z axis. We have selected line, we have selected the axis, we have selected the solid, and we'll say trim. And you can see the solid is trimmed. But the problem is it has also trimmed the lower portion of the solid. So we'll go to the merge option in the solid edit panel. We'll select this solid and this solid and we'll merge them. Okay, done. One more thing that we have to do is we can split this nozzle. We don't need to split this nozzle. It's okay. That's cute. Okay, so we have done our cat cleanup thing. We have this 1, 2, 3, 4, 5 different solids with us. 5 different solids with us. So let's just now organize these solids into different components. So just use your right mouse button to create a new component, and I'll name this component as top end. Okay, then I'll create one more component and I'll name it as bottom end. Then I will create a new component, I'll name it as shell, and then one more component, I'll name it as nozzle. Okay. So to change the colors of this component, you simply select all these components, use right mouse button and just click on auto color. So colors automatically change. Now why I did this? Okay, the reason behind it is the shell material will have different properties, and might be the head material, dish end material will have different properties, and definitely the nozzle material will have different properties. To assign these different properties, we need their respective elements in different components, and that's why I've created these many components. Okay, now we'll move the respective solids into the respective components. Okay, so to do this, you can go to tools page, and you have to open the organize panel. Okay, the shortcut for this is you have to press shift and F11 from your keyboard and you will get into the organize panel. Okay, now we will have to select solids here, because we have to organize the solids. Okay, now the destination component here is nozzle. So first of all, let's select nozzle, solid, this one and this one. I want these are the parts of the nozzle, so that's why I want them into the component name nozzle. Okay, good. Now let's change this destination component to top end. Okay, I want this solid to be in the component name top end, and similarly I want this solid to be in the component bottom, and I will simply select the solid, simply select the destination component. I will click on move. Now the remaining two solids, I want them to be in the shell component, so I'll select them and I will move them into the shell component. Good. So now if you turn the viewing preferences by component, you can see that solids are in respective components. Now I no more need this node, so I will clear this node. To clear all those temporary nodes, what you can do is you go to geometry page and this temp node panel. The shortkey is shift and F2, and I'll say clear all, so all temporary nodes will be cleared. Okay, and okay, now go to delete panel, select here components. Now if you click on preview empty, it will show that one entity is empty. Now this one entity is a practice component, wherein now there is nothing in the practice component. So if you isolate practice component, okay, you just right, okay, click on practice component. Okay. If you right click, if you right click on the component name, and if you say isolate only, it will isolate that component only. So you can see that there is nothing in this practice component. So to delete this empty component, we simply go to delete page or delete panel. I'll click on components, I will click on preview empty, and then I'll say delete entity. So all the empty components will be deleted. The component, so if you press F from your keyboard, it will automatically fit all the geometry within the screen area. Okay. Now let's start meshing this model. Okay, we'll start with the most critical area, that is the nozzle area. Okay, what we have to do is we'll first mesh this surface, a 2D surface with 2D elements, and then we'll map this solid using these elements. It's very simple. Just go to 2D page, click on click to open the Hypermesh panel. Okay, or the shortkey is, or you can use the shortcut key, that is F12. Just simply press F12 from your keyboard and it will open the Hypermesh panel, 2D Hypermesh panel. Okay, click on the surface. Okay, we first of all, let me tell you about the different algorithms. Okay, we will be using the size and bias algorithm. There are 5 different algorithms here you can use for using Hypermesh. Okay, but I will stick to the size and bias algorithm. So why I show now? Okay, I will click on the surface, I will choose the size and bias. I'll click the mixed I want the mixed type of mesh. Here we can change the kind of mesh you want. You want chords only, you want triads only, you want mixed. So I will always use the mixed option. So it will put chord element as far as possible, and if not possible, it will create some triads. Okay, you can change the default element size. It is the maximum size of the element that Hypermesh will put into the surface, but I am not going to change all these things. Okay, I'll simply click on the surface, and I will, okay, this is very important, this option, element to surface component and elements to current component. So if I click on elements to current component, it will create the elements in the component that is currently active. So if I click on top end and make it current, if I mesh it, so if I mesh it, and you can see that these elements should be in nozzle component, but it has created them into the top end component. I don't want this, so reject. So you have to make sure that this option is set to elements to surface component, and we will be creating only first order elements. Okay, great. So click on the surface and mesh. Now you can see that it is the Hypermesh is creating one element here. Okay, or simply you can see that it has divided this whole edge into 3 different edges, and that is because of this solid. So we won't get a very good kind of mesh in this situation. To deal with such situations, you can take some additional surface splits here and here, and to do that we'll go into the quick edit panel, that is just press shift F11. Okay, we'll use these options: split, surface and line option. Okay, so I just select one point. Okay, I select this point and I select this line. Okay, it has created the surface split. Great. Similarly I do here, I select this node and I select this line. It has created that. Okay, so again go to the Hypermesh panel, press F12, select this surface and just mesh it. Okay, now it has created only a single element here, but I want at least 3 elements across this direction and also across this direction. So why do I want 3 elements, at least of 3 elements here? Okay, so if we mesh with a single element, we won't be able to capture the bending stresses or bending effects in this solid, and to capture the bending stresses all those things, you have to have at least of 2 elements across the thickness. So to be on a very good side, I want to have at least of 3 elements. Now here it has created 4 elements across this larger edge, but as you can see, this element is very small and this element is very big, so it's a very big jump over here. I don't want that, so I'll simply change the density. You just have to click on this number and the density will be changed. You click, and 15 sounds good. Let's make it 15. To reduce density, you just okay, to increase it you have to click left click, and to reduce you have to right click, mesh. Still it's not very good, so what I can do is I can create 2 more elements. Let's give it a try. This is much better. And if you press your mouse wheel, it will automatically finish the operation. Okay, similarly mesh the surface. Great. And then mesh the surface. 6 over here. 7, 8. Okay, 7 is good. Okay, now let's go to the 3D mesh panel and go into the solid map. Open the solid map panel. Okay, now we have to create a 3D mesh in this portion. So what we'll do is we will use this one volume option, since it's very okay. So I'll go to the 3D mesh page and I'll go to solid map panel. I'll use this one volume option. Simply select this solid, select the source face. Okay, the Hypermesh algorithm will carry the mesh from the source face into the body and at the destination face also. So I'll select this as the destination surface, and I want 20 elements across in between this source and destination faces. So I will set the density to 20 and I say mesh. Okay, it is saying that no solid is selected, so just select this solid and you can see that solid is a mesh. So if I click on this wireframe view, we can easily see that what kind of mesh it has generated. Okay, looks good. Okay, no problem, it's a kind of acceptable mesh. Everything is good. Now we'll similarly map this solid. Select this solid, select the source face, select the destination face, and I want 20 elements only. Okay, the mesh is created. Now we will mesh this shell. We will mesh this shell now. To mesh, okay, to have a proper element growth, I will take a Gaussian split at of this edge. Okay, and to do that, just simply open the quick edit panel, press F11 from your keyboard, and you can set the washer split value. So it will offset that edge in all the three directions by 15 mm. So I have set the value as 15 mm, and now I will select the lines. Okay, I want washer split for this line, so I select this line. Okay, and you can see that it has created the washer split. It has created washer split on both the shell. If I turn off the elements of the nozzle, okay, it has created the washer split in shell also and the nozzle also. It will project that edge in all the three dimensions. Okay, I don't want this edge, so I have to unsplit the surface. So I will click on the unsplit surface. I will click on this line. So you can see that there is no the edge. There is no more any split on that surface. Okay. Now let's mesh this surface. So open the 2D auto mesh panel using F12 key. Mesh. I will set the density as 5 here, 5 here, and I want 20 elements here. Mesh. So you can see that the flow is pretty good, but still these elements, okay, there is kind of jump over here. To avoid this jump, I can use the biasing option. All you have to do is click on biasing. That's why the name of the algorithm is size and biasing. So if you okay, just as you adjust, you can adjust this biasing in a very similar way to the density. So I am setting a biasing of minus 1.5, or I can go to minus 1.8. Similarly on this edge, on this edge you have to create in positive direction. You simply see the movement of nodes and mesh. Okay, now you can see that the elements are element growth rate is proper, the growth is proper. Okay, and just say mesh and everything. Okay, those are the kind of mesh we want. Now I will mesh this surface. Select this surface, mesh. I want at least 4 elements over here and over here. Now I change this density. Okay, so there are like different options to change this density. You can simply click on this number and you can move your mouse up and down to change number of elements you want. So I set this as 30, and on the bottom edge I will set 25 elements. Okay, now this is a pretty good mesh, but the only problem is here you can see that there is very big element here, very small element. So we can increase this element, this density of this edge. Okay, it seems pretty good. It has created a lot of trials, but that will be okay for it won't cause any issue. We can avoid those trials also, but as far as this mesh is concerned, I think this is a very good kind of mesh. Okay. So now we'll mesh this surface. We'll simply change the density of this edge to 35. Okay. Now change to this 35 also. Okay, 35 will be too, it will get very small elements. Okay, 30 is good. 30 here also. Okay, very good. Now we will map these two solids of the shell. Okay, what you have to do is you go to 3D mesh page and go to solid map panel, select one volume, select the solid, select the surface and this surface, and select this inside surface as the destination surface. So I have selected this outside surface as the source surface, the surface that we have meshed as the source surface, and the surface, the inside surface as the destination surface, and I want 3 elements. So even if you don't change the density, it will automatically pick up the density because the elements over here will be okay. To maintain the connectivity, software will automatically take connectivity from this element. So even if we keep here 20, it will create only 3 elements across this thickness. So it's a mesh. Okay, the meshing is done. So you can see that it has picked only, so it has created only 3 layers of the elements. Similarly, we will map this solid. Select this solid, select the source surface, select the destination surface. Right. Similarly, we will create mesh for the 2 ends. Go to 2D auto mesh panel, mesh this surface, increase the densities from what I will make it 25, not 35. Okay, it's good, it's acceptable. 10, match this surface to mesh 25 mesh. I will again create the 3D mesh for the same heads. Go to 3D mesh panel, go to solid map. Okay, we'll use one volume one more time. Select this solid, select the source face, select the destination face, and pick mesh. Okay, mesh is created. Select this solid, select this surface, select the destination surface, and click mesh. Okay, so in this way I have created a complete 3D mesh for this geometry. Now we will create the rest of the half of this mesh. So to do that, we'll simply we have to reflect these elements about z-axis plane, and that's why we have to select y-axis in the reflect panel. So we will go to tools, and here is the option reflect. So we want to reflect elements. You can reflect nodes, elements, components, lines, everything you want. So I will select elements, and I will select elements displayed. So I have selected all those elements that have been displayed on the screen. Okay, and I will select y-axis. So if I want to reflect elements about z-x plane, I have to select the remaining axis, that is y-axis. If I want to reflect them about z-y plane, I select x-axis and so on. So in our case, the reflection plane is z-x, so we will select y-axis. Okay, and you have to select a best node. Okay, about which node you have to reflect the element. So I will select this node, and before that I will go again into elements, and I will set duplicate them to original components. So if I reflect without duplicating, the same elements will be reflected on this side, and I don't want that. So I created some duplicate elements, and now I am reflecting them. Okay, we have reflected the elements, and you can see that very easily we have created the rest of the half of the mesh very simply. But there is one problem. After reflecting the elements, even though you cannot see, but these elements are not connected. So there are two nodes at almost at the distance of almost 0 from each other, but they are not connected. So we don't want that. So we have to connect these elements. So just click on the XY view. And how can we do that? Go to tools page and open the faces panel. Now select the elements. To select the elements by window, you can simply press shift and use your left mouse button to drag a window, and all the elements will be selected inside that box or inside that window. Okay, so now I'll set this tolerance as 0.1 itself. Okay, because I know that the gap is not more than 0.1 mm between those two elements or those two nodes. Okay, so I'll click on preview equivalence, and you can see that it will show you where the nodes are away from each other, that where are the nodes not connected, which nodes are not connected. So here you can see that it has created the whole line of symmetry. And now I will click on equivalence. Great. Now the complete mesh is connected. Okay. Now what we have to do is, okay, we have created our hex mesh. Now it's time to create some it's time to make this mesh usable for Ansys mechanical utility. So what you can do is you can go to preferences and you can go to user profiles. Now here you have to choose profile as an Ansys. Okay, select Ansys, click OK. Now just go to this utility tab in the navigation panel and click on material. Now we can create now you can see a pop-up window. Here you can create your materials. I'll click on new. I'll simply keep its name as steel, suppose, and ID as 1, and I will assign it green color, and you just reduce this number of temperatures to 1 because we will be assigning properties, or we will be creating properties at only one temperature. That's why 1. Okay, so EX is the modulus of elasticity in X direction, and since we are going to use it isotropic, it doesn't matter if we give it for X, Y or Z. So I will simply select X and then new XY. So it's nothing but a Poisson's ratio, and I'll put the value of what you can say elasticity, modulus of elasticity, as 2e raised to 5, and the Poisson's ratio is 0.3. Okay, so we have created our material. You can see this in the materials list. Close this window. Now go to element types. Okay, we have to create a new element, so we'll be using solid 185 elements for this simulation. Okay, I'll remind you that I am going to simulate this same model in my next tutorial in mechanical APDL. So I would select element type as solid. Okay, solid 185. It's a 3D element. You can read more about in Ansys help menu. Okay, create this element type. Close. Now open this component manager. You can see that all 4 components are shown here. Use your right mouse button and make this table as edit table. Okay, now you can edit this table. So for all the 4 components or all the solids, we will be using okay, let's create one more material. Okay, material. I'll create one new and I'll say as nozzle. So it will be material for nozzle. Let's assign this material different color, yellow, suppose. Okay, and reduce the temperature to 1. Great. So EX and new XY. So I'll assign it as 1.8E5 and Poisson's ratio 0.3. I'll create it. Now again open the component manager. So we'll be assigning the material steel to top end, bottom end, and the shell. So click here, click on match number. So I want to assign these 3 components the material steel, so I will assign them steel. Here you can see that for the component top end, bottom end, and shell, the material is steel. Okay, and now for this 4th component, I want to assign the material nozzle. That is, I will assign the material nozzle to nozzle. Okay, we have assigned. Now it's time to assign the element type. So we have created only single element type, that is solid 185. I assign. Now let's see what happens. Okay. it's showing that invalid element type. So why it is showing that? Close this window. It is showing that the element type we have assigned is invalid to this component because for meshing this creating this 3D mesh, we created some 2D elements, but we haven't the 2D elements are still there, and we cannot assign a 3D element type to a 2D element. So simply we have to delete all those 2D elements and keep only this 3D elements in these 4 components. So how can we do that? Okay, simply go to this mask tab. First of all, click on unmask all. This icon represents the unmask all option, so it will unmask everything. And then simply click on 3D. You have to click on the minus sign so that the software masks all the 3D elements. It has masked all the 3D elements. And now open the 2D or open the delete panel using F12 key on your keyboard. Select elements here and elements, and you have to click display. Okay, delete. Great. So all the 2D elements are deleted, and okay. Now click on unmask all option, so you can see all the 3D elements once again. So again go to utility component manager, and now you can see that the software has assigned the element type as solid 185. Okay, so we are good to go. So we have created properties, we have assigned the material properties, we have assigned the element properties. Now only one step is remaining. To simulate any analysis in Ansys, you have to create some entity sets to apply your boundary conditions, and to do that I'll also create some boundary conditions or entity sets here. It's very simple. Okay, let's mask half of this element, and I'll tell you what I want to do is, okay, you can go to tools page, and you can open the mask panel. The short key is F5. Simply press F5 and you will get into the mask panel. Select elements over here, drag a window, mask them. Now since it's a pressure vessel, okay, I'll turn off the geometry for all the 4 components. Okay, now since it's a pressure vessel, pressure will act inside of the shell and the nozzle. So we have to create one entity set for the pressure, and then we will apply some compensating pressure on this face of the nozzle to keep the component in equilibrium. So I will create 2 entity sets, one for the pressure and one for the compensation. So unmask all elements, then simply go to analysis tab, open the entity sets panel. Okay, now you name the set pressure. Suppose the set will contain nodes, so that's why nodes, and I'll click on this node and this node. So I have selected one node on the interface of the nozzle and one node on the interface of the shell, and now I will click on biface. Okay. Now you can see that if you zoom out a little bit, you can see that it has selected nodes all over the face. Okay, so we can create this entity set. Now we have to create entity set of compensation, so I'll name it as compensation. Okay, great. Select this node, select any one node on this face, and then click on biface, create. Right, so in this way we have created the entity sets also. Okay, we have created materials, 2 materials, element types, and 2 sets. Okay, now if you want to see what material, like which component has what material, you can simply click here and buy Mac. Okay, and you can see that the yellow color is for the nozzle material and the green color is for steel. So you can very simply get that if you assign the material properties correctly or not. by element type you can also see, I guess. Okay, it is showing that there are all the elements are 3D. Okay, great. So everything is good, and I think we can export the solver deck for the model. So just save this file, save this model. I'll save this as practice, save. Okay, and now we will export the solver deck for Ansys. To solve the analysis in Ansys Mechanical APDL, we have to export the solver deck, and we can do it very easily. Just click on this export solver deck icon and choose the location where you want to export that solver deck. So I have location, and simply type the name that you type the name for the file. Okay, file exported temp. Okay, and the format, you can choose the format of the database, either as a CDB command database, or you can simply click here and type .db to export it as only database file. But I'll suggest you to export it as a CDB file, because it avoids error in okay, while exporting the database software, sometimes get confused between okay, to maintain the compatibility of the Hypermesh and Ansys, it's better to export it as a CDB file. So I will simply keep it as CDB file. I'll export. Now you, as saving doesn't export to the database, so just click save and then say export, and just watch here. Okay, finish. So it has exported the CDB file. Okay, let's see if it has exported or not. Okay, let's go to desktop. Okay, it has exported a CDB file. Great. So in this way we have covered all our topics. We have exported the solver database. Okay, thanks for watching the video. If you like it, just subscribe our channel for more, and if you have any doubts regarding Hypermesh meshing or APDL analysis, you can contact me.